Alright, here's an example of graphing a more complicated type of function like this. So this is a graphing y equals a sine omega x plus b, or y equals a cosine omega x plus b. So functions like these are called sinusoidal. So that's written like this. So if you're talking about graphing a sinusoidal type function, then that means something like this or something like this. Or they could have phase shifts, so we're not graphing anything with a phase shift yet. So we talked about phase shifts a little bit in an earlier video, but they're not really relevant here. But that'll come up a little bit later. So sinusoidal function means something like this or something like that with a phase shift. But anyway, I just want to point out this vocab word here. In case it comes up, then you'll know that it just means something like that. Okay. Anyway, so the example here is to graph y equals -3 cosine of pi over 4 times x, and then plus 1. Okay, so we have pretty much almost everything going on here, right? So we could do the transformation techniques from pre-calculus, but since trig functions have those periodic properties, right? So we can actually exploit those to make this a little bit simpler. So if we really wanted to, we could do the pre-calculus transformation techniques. I don't know about you guys, I don't really want to do those here. So let's do, we're going to follow these other steps here that we can use for cosine and sine. Okay, so what we're going to do is go through these steps, and then we're eventually going to plot what this looks like on some graph paper here. So if you want to follow along with graph paper, but if you don't have any, check the video description. There will be a link. You can click that link, open up a PDF file with some graph paper and print that out if you want to follow along. Okay, so let's get started. So step 1 is find the period t. Okay, so remember the period we talked about in a previous video, or we talked about it quite a bit in a few videos, but more recently we talked about it as this capital number t. Okay, so the first thing we want to do is find the period t. Okay, so that's our first step. So t, can you remember t equals 2 pi divided by the absolute value of omega. Okay, but what's omega? Remember, omega is the thing being multiplied by the x, so in general we have y equals, in this case, actually we already have it written down up here. So here y equals a cosine omega x. So here's our omega, the thing being multiplied by the x. So in this case, omega is pi over 4. Okay, so omega is pi over 4. Okay, so then t equals 2 pi divided by pi over 4. Okay, because absolute value of omega, well, omega is already positive, so the absolute value doesn't really do anything, so we can just drop it. So then we have 2 pi divided by the quantity pi over 4. So if you divide by pi over 4, you're multiplying by the reciprocal, which is 4 over pi. The pi's cancel, that's great, and we get 2 times 4, which is 8. Okay, so the period is t equals 8. Okay, so that's step 1, find the period t. Okay, find the period t. Okay, so not too bad, right? Step 2, divide this interval 0 to t into 4 subintervals of equal length. This will make 5 x values. Okay, so this step sounds kind of complicated, but it's actually really not that bad, especially since we have the number t equals 8. That's a nice number, that's really good for us. So this is interval notation again, but you don't really have to know or be comfortable with interval notation to do this step. You'll definitely want to know it anyway, especially if you're going on to further math classes, but you don't have to know it for this particular process here. But I definitely recommend that if you don't know it, definitely learn that for sure. It'll make your life a lot easier in math anyway, and perhaps more generally also. So anyway, what we do for step 2, it's actually quite simple. So we just go from 0 to t. So here's what we do. For step 2, let's maybe use a different color now. For step 2, what we do is draw ourselves a little line here. So we go from 0 to t. What was t? T was 8. So we go from 0 to 8. Okay, and we want to divide this interval from 0 to t, divide that into 4 subintervals of equal length. So what that means is just divide it in half. Okay, so if we divide it in half, what is this point? Well, halfway between 0 and 8 is 4, right? Then we divide each of these guys in half. So from 0 to 4, halfway in between is 2. From 4 to 8, halfway in between is 6. Or if you're unsure of that, 4 plus 8 is 12. 12 divided by 2 is 6. Okay, so we're really just finding like a midpoint or an average here. Okay, so add up these two guys. 4 and 8 divided by 2, you get 6. Like here, 0 plus 4 is 4. Divide that by 2, you get 2. Okay, 0 plus 8 is 8. Divide that by 2, you get 4. Okay, so just that's it for step 2 really. So we just drew this little piece of the number line from 0 to 8, divided in half, we got 4, divide each of these two pieces in half, we got 2 and 6. Okay, so that's it. Now we have 4 intervals, this interval, this interval, this interval, and this interval. Okay, but we don't care about the intervals, which is nice. All we care about is these, this will make 5 x values. Okay, so here's our x values, 0, 2, 4, 6, and 8. Okay, so these are the x values that we're concerned with now. And then step 3 is find the y value at each of these x values. Okay, so what we do, so this gave us 5 x values. Now what we do, we take these x values and plug them into the original function here. Okay, and then we get the corresponding y values. So let's go ahead and do that now. So when x equals 0, let's see what happens. So when x equals 0, what do we have? When x equals 0, we have y equals negative 3 times the cosine of pi over 4 times 0 plus 1. Okay, so that's negative 3 times the cosine of 0 plus 1. Cosine of 0 is 1, so this is negative 3 plus 1, which is negative 2. Okay, so negative 2. Okay, so this corresponds to the point, let's write it down over here. This corresponds to the point when x is 0, y is negative 2. So that corresponds to the point 0, comma, negative 2. So that gives us, let's maybe write it over here. Now we'll write it up here. 0, comma, negative 2. Okay. So that's if x is 0. Okay, what if, so what's the next one? X equals 2. Okay, so when x equals 2, yeah, I kind of wrote that in a bad spot. Let's get rid of it. We'll just get it all at the end. So when x equals 2, still all over the place here, what's going on? Y equals negative 3 times the cosine of pi over 4 times 2 plus 1, which is negative 3 times the cosine of, so pi over 4 times 2 simplifies to 2 pi, or that's 2 pi over 4, which simplifies to pi over 2, and then plus 1. Cosine of pi over 2 is 0. Negative 3 times 0 is 0, so that's 0 plus 1, which is of course just 1. Okay. So when x equals 2, y equals positive 1. Okay. What about when x is 4? When x equals 4, y equals negative 3 times the cosine of pi over 4 times 4 plus 1. Okay, so remember it's pi over 4 times x, so if x is 4, this is pi over 4 times 4. And then we have negative 3 times the cosine of, so pi over 4 times 4, the 4's canceled, that's great, we're left with pi, and then plus 1. Cosine of pi is negative 1, so this is negative 3 times negative 1. Negative 3 times negative 1 is positive 3, so this is positive 3 plus 1, which is 4. Okay, so when x is 4, y is also 4. That's nice, I guess. X equals 6 is next. So then what we have here is y equals negative 3 times the cosine of pi over 4, times 6, and then plus 1. Okay, so remember it's negative 3 cosine pi over 4x plus 1. So if x is 6, then we have negative 3 cosine pi over 4 times 6 plus 1. So this is negative 3 times the cosine of 6 pi over 4 simplifies to 3 pi over 2. We still have the plus 1 floating around out here. And then cosine of 3 pi over 2 is 0. Okay, so we want to know that from the unit circle. Cosine of 3 pi over 2 is 0. Negative 3 times 0 is 0. So this is 0 plus 1, which is just 1. Okay. So now x equals 8 is the last one here. Okay, so again, what are we doing? We're doing step 3, which is find the y value at each of these x values. Okay, so we got 5 x values from step 2, and now we're going to use each of these x values to get the corresponding y coordinate, or y value, on the graph. So at x equals 8, we have y equals negative 3 times the cosine of pi over 4 times 8 plus 1, okay, which becomes negative 3 times the cosine of 8 pi over 4 simplifies to 2 pi, so that's cosine of 2 pi, and then plus 1 cosine of 2 pi is positive 1, so negative 3 times 1 is negative 3. So we have negative 3 plus 1, which is negative 2. Okay? And actually, for x equals 8, we didn't really have to go through that. Why not? Because we know the period is 8. So 0 and 8, at x equals 0 and x equals 8, the y-coordinate should be the same. Okay? Because these are 8 units apart, the period is 8. So if you start at one value, go 8 units in either direction, to the right or to the left, you're going to get the same y value. Okay? So if we start at 0, go 8 units to the right, we'll get the same y value. Okay? So x equals 0 gives us y value of negative 2. X equals 8 better give us the same y value, negative 2, right? Because the period is 8. Okay, so we don't have to go through all that, but the reason I wanted to write it all out is because I wanted to point something out. First, that's it for step 3, find the y value at each of these x values. So what did I want to point out? Notice here, when we simplified, what did we get? Blah, 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 negative 3 cosine of 0. Okay, we had a 0 in here. So here we had 0. Blah, 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 pi over 2. Okay, when we did the second one. When we did the third one, blah, 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 pi. When we did the fourth one, blah, 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 3 pi over 2. When we did the fifth one, blah, 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 2 pi. Okay? So the pattern I want to point out here is when you plug in the first number from here, you simplify, and inside the cosine you get 0. When we did the second number, we simplified inside the cosine, we got pi over 2. The third number, inside the cosine, we get pi. The fourth number, inside the cosine, we get 3 pi over 2. The fifth number, inside the cosine, we get 2 pi. Do those numbers sound familiar? 0, pi over 2, pi, 3 pi over 2, and 2 pi. Hopefully those do sound familiar. Those are nice numbers that we've been seeing on the unit circle and on the graphs also. So this will always happen. If you follow these steps, if you follow them carefully and exactly as they're written, just like we did here. So make sure you do 0 to t. Okay, you can use other intervals, but if you do 0 to t, like we did here, 0 to 8, okay, because t was 8, so 0 to 8, if you use that exact interval, divide it up into 4 subintervals, you get these 5 values. Plug these 5 x values into the function, then when you simplify inside of the cosine or the sine, same thing either way, when you simplify inside, you'll get 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? So it's just a nice way to check yourself. I wouldn't really use that fact to evaluate unless your instructor says it's okay to do that. I'd be careful with that though. But you know, use it to check yourself. Just use it to make sure that you're going on the right track and things like that. But anyway, just wanted to point that out there. So that's a nice pattern to observe. That's a nice thing to know that happens. So now step 4, plot the points and smoothly connect and extend the graph as needed. Okay, so what are the points here? So when x is 0, y is negative 2. Okay, so this is the point 0, comma, negative 2. When x is 2, y is positive 1. So this is the point 2, comma, 1. When x is 4, y is also 4. So that's 4, comma, 4. When x is 6, y is positive 1. So that's 6, comma, 1. And when x is 8, y is again negative 2. Okay, because remember we talked about the period being 8. So at x equals 0 and x equals 8, we should have the same y value, and we do. So this is 8, comma, negative 2. Okay, so now what we have here are 1, 2, 3, 4, 5 points that we can plot on the graph. So let's bring out our graph paper here. And again, if you want to follow along with graph paper but you don't have any, go ahead and click that link in the video description, print out some graph paper, and you'll be good to go. Okay, so let's set up our axes here. So I'll probably make it way too big. But no harm in that, I guess. Alright, zoom back out a bit. So x-axis, y-axis. If you're following along, you don't really have to make yours exactly like this. You just want to make it big enough to fit these points here and some extra space around them too. So this was 4. Probably going to erase that a little bit again. So anyway, what are the points we want to draw? 0, negative 2. So first let's set up a scale here. Let's just make each grid mark 1 unit. Okay. So yeah, I really didn't have to make it this big. But anyway, 0, comma, negative 2, that's the first point we want to plot. So here's 0, and then negative 2 is going to be 2 units down. So here's 0, negative 2. 2, 2 comma 1 is next, 2 comma 1. So that's going to be here, 2 comma 1 up here. Okay, what's next? What was next was 4 comma 4. So let's plot that, 4 comma 4. So that's going to be 4 comma 4 up here. Okay, and then what came after that? 6 comma 1, and then 8 comma negative 2. Okay, so 6 comma 1 is over here. Oops, it's over here. And then 8 comma negative 2 is down here. Okay, so step 4 says plot the points and smoothly connect and extend the graph as needed. Okay, so you know, we want to be very, very, very careful here. So it looks like we can connect these in a straight line, right? And we actually can, but we absolutely do not want to do that, because what are we doing? We're graphing a cosine function, and cosine and sine, they're not straight lines, okay? They have that little curviness to them. So what we want to do is connect this kind of curvy style the way that a cosine function looks. So curviness through here, curviness through here, more curviness through here, and then some through here also. Okay, so let's label these points too, just to be thorough. So this is 0, negative 2, this was 2 comma 1, this was 4 comma 4, this is 6 comma 1, and then this is 8 comma negative 2. Okay, okay, so this also says extend the graph as needed. So we weren't really specified how many cycles to draw. This is one complete cycle. It's not really good enough. Let's maybe draw a little bit more. So if we want to keep going this way, how far can we go? Well, this is where we can use the period. Okay, so we know the period is 8. So if we start at this point, go 8 units to the right, we're at the same y-coordinate. If we start at this point, go 8 units to the right, we're at the same y-coordinate. So 2 comma 1, if we go 8 units to the right, where are we? We're going to be at 10 comma 1, which is right here. Okay, so this is 10 comma 1. If we are at 4 comma 4, go 8 units to the right, where are we? We're at 12 comma 4. Okay, why 8 units to the right? Because again, we found out earlier, way back at the beginning of this video, that the period is 8. Okay. So anyway, continuing this, 6 comma 1, if we go 8 units to the right, we'll be at 14 comma 1. And then 8 comma negative 2, go 8 units to the right, we're going to be at 16 comma negative 2. Okay, and we connect this again cosine style. So let's label these again. So that's, or sorry, 16 comma negative 2, I don't know if I said that right. So this is 14 comma 1, and then this is 16 comma negative 2. Okay, so 8 comma negative 2, 10 comma 1, come up here, yikes, through 12 comma 4, and then through 14 comma 1, and then down here through 16 comma negative 2, and then we'll keep going back up and then infinitely far in that direction. So let's also extend it this way too. Just to we'll get one more cycle in the negative direction because we don't want to leave out this side of the y-axis for some reason. So what we can do is just look at this part of the graph here. So if we go 6 comma 1, if we go 8 units to the left, where are we? We're going to be at negative 2 comma 1. What if we are at 4 comma 4? If we go 8 units to the left, we're going to be at negative 4 comma positive 4. Okay, so this is negative 2 comma 1, negative 4 comma 4, and what else is going on? So now 2 comma 1, if we go 8 units to the left, we're going to be at negative 6 comma 1. So that's right here, negative 6 comma 1. And then 0 comma negative 2, if we go 8 units to the left, we'll be at negative 8 comma negative 2. Okay. Okay, so connected cosine style, I actually did a pretty bad job right there. Cosine style, let's maybe come up this way. So for me it's easier to go from left to right for whatever reason. But please do whatever's easier for you, of course. So that's now 3 complete cycles. We'll extend a little bit over here, so we won't go one more, but we'll just stop it here. So let's zoom out a bit. Okay, so here's 3 complete cycles. Okay, right here. So from here to here is 1 cycle. here to here is another cycle, and then here to here is our third cycle. And of course we want to extend a little bit in either direction to just show that the graph goes infinitely far in both directions. So that's it for this example. So we see that it is a little more complicated, but it's not as bad as you might think, because I know this video is kind of long, but that's just because I wanted to take time to explain all the details, and also of course point out this pattern with the 0, pi over 2, pi, 3 pi over 2, and 2 pi, and things like that. Okay, but when you go through these steps here, these steps really aren't that complicated. They might sound kind of complicated, especially step 2, but step 2 is really not that bad. Most of these steps really aren't bad at all. Okay, and as long as you have a nice kind of grid to work with, graphing might be the trickiest part, but if you have a nice grid or a nice scale setup, you'll be okay. Okay, so that's example 1 with graphing a more complicated type of trig function. Another example coming up in the next video.